Hi everyone. Welcome to Blockchain. My name is Adugbo Victory. I would be your facilitator for the blockchain program. Welcome, it's good to have you here once again. So, what is the blockchain? The blockchain is basically a type of a distributed ledger technology that records transaction across a network of computers in a way that is secure, transparent, and extremely resistant to tampering. At its core, blockchain consists of a chain of blocks, and each block contains a list of transactions and a reference, which is basically a cryptographic hash or a reference to the previous block. And the way these blocks are basically linked ensures that once data is recorded and confirmed by the network, it basically becomes very difficult to alter. So, in essence, blockchains provide an immutable record of transactions agreed upon by a decentralized network of participants. So, highlighted on the screen are some of the things that make up a blockchain: a distributed ledger, it's secure and transparent, it is decentralized, and it is also immutable. So, how does a blockchain work? There are a few steps to how basically a blockchain works. So when a user initiates a transaction, it is packaged into a candidate block along with other transactions and nodes, or what a lot of people know as miners or validators, depending on the consensus mechanisms, then compete to collaborate or validate this block. And once it is validated, the new block is cryptographically linked to the previous block by including the previous hash in its header. And this process basically repeats itself and forms a chronological chain of blocks. So each previous block hash serves as a tamper resistant seal, so that anyone that decides to change data in the old block would result in a change in the hash. So that basically breaks the chain consistency. So through the combination of distributed storage, the consensus verification, and cryptographic linking, blockchains achieve what we know as decentralization, which means that there is really no single point of control, and also transparency, because all members of the network can basically verify all transactions, and transactions are very extremely hard to falsify once they have been confirmed, which is basically the security part of the blockchain. So we're going to talk about different types of blockchain. First, we have the public blockchain. These are open permissionless network that anyone can join and participate in. So this means that all transactions in the public network is fully decentralized. It is visible to the public completely. And public blockchains rely on a consensus algorithm like proof of work or proof of stake to validate blocks in a trustless manner, because they are open to anyone. They prioritize security and censorship resistance at the cost of scalability. An example are Bitcoin and Ethereum, which are public blockchains. So anybody in the world can basically run a node, make a transaction, or become a miner or validator. We also have the private blockchain. These are permissioned networks operated by a single organization or a closed group, which means that participation is restricted. So you must get an invitation or be authorized before you can run a node, read the ledger, or submit transactions. And the private blockchain still uses blockchain data structures, but on a much smaller scale and with centralized control. We also have hybrid blockchains. Hybrid blockchains basically combine elements of both public and private networks. This means that in hybrid model, certain data or transactions are kept private and accessible to only authorized participants, while other parts of the blockchain may be open or periodically anchored to the public chain for transparency, right? So we also have what is known as a consortium blockchain or federated blockchain. So this is a special type of blockchain that is governed by a group of consortium or organizations rather than a single entity. So this blockchain is private to the group but decentralized among the members of the consortium who basically collectively make decisions and run validator nodes. And this model eliminates the risk of one entity having total control, like in the private blockchain, and still restricting access to a known group of participants. So we have key concepts in the blockchain. What are some of the key concepts in blockchain? We have decentralization. Decentralization basically refers to the distribution of control, right, and authority across a network rather than a single point of authority. So the significance is that it enhances security by eliminating a single point of failure, which ensures that there is absolute control over the system and the blockchain is resistant to censorship and interference. We also have the distributed ledger, which is a database that is replicated and shared across multiple nodes in a network. We have blocks. Blocks are individual units of a blockchain, and each contains a group of transactions and metadata. The metadata basically is the timestamp and the previous block hash. We also have hashing. Hashing basically involves converting data into a unique fixed length strength of character, which is known as a hash, using a cryptographic algorithm. We also have nodes. Nodes are computers that participate in a blockchain network by storing a copy of the blockchain and validating transactions. We also have cryptography, which involves using encryption techniques to secure data and verify identities. And this is basically fundamental to blockchain security because it enables secure transaction verification and the protection of user identities and data. We also have the consensus mechanisms or consensus, which refers to the way by which nodes in the blockchain network agree on the validity of transactions and the order of blocks. The way consensus is achieved in a node is basically the same, and this is basically done to prevent double spending and fraud. Then we have smart contracts. Smart contracts are self-executing contracts with the term of the agreement written directly into the code, and smart contract basically automate and enforce this agreement without the need of an intermediary. So this reduces drastically the potential for disputes. So when we talk about consensus mechanisms, right, we have a couple of them. We'll be definitely talking about them in depth. We start with the proof of work, which is basically the first widely used consensus mechanism. It was introduced by Bitcoin. Miners basically compete to solve a cryptographic puzzle, and this basically requires significant computational power and energy. But the first miner to get the right answer earns the right to add the new block to the chain and receives a block reward and transaction fees in return. So proof of work is high security but energy intensive. It was first used by Bitcoin. Now the second one is proof of stake, which is a newer energy efficient consensus mechanism. And instead of expending computing power Validators in proof of stake, they stake cryptocurrency as a deposit or as a collateral to secure the network. So this is energy efficient, faster block time, and it was basically implemented by Ethereum 2.0 after a fork was completed. Other types of consensus mechanisms include DPoS, which is delegated proof of stake, POA, proof of authority, BFT, Byzantine fault tolerance, and other hybrid approaches that are coming up. There are a lot of consensus mechanisms like we've discussed earlier, and the consensus mechanisms basically depends on the network generally. So we already spoke about smart contracts. These are self-executing code. They are automatically enforced and they are programmable blockchain, which means that they enable complex applications beyond simple transactions. It's important to know that smart contracts are what are used to power decentralized application dApps, decentralized finance protocols like Aave, Uniswap, and NFTs. So Ethereum was basically the first platform that popularized smart contracts with their EVM machine. So what are some of the blockchain applications, right? What are the applications of blockchain in real life? We have financial services, things like cryptocurrency, decentralized finance, cross-border payments, central bank digital currencies. And in the supply chain, we have things like provenance tracking, anti-counterfeiting, logistics automation, real-time auditing. And in the healthcare sector, we have medical records, data sharing, drug traceability, and patient privacy. And other applications include digital identity, voting systems, intellectual property, and Internet of Things. A more detailed explanation would be included in the LMS, so everything is basically explained better in the LMS. So do well to read in details what is included in the LMS. So we also have security concerns. This is a new technology, and with new technology there are basically security concerns. We have network vulnerabilities. Sometimes smart contracts are attacked. We have attack like the 51% attack, cyber attacks, or consensus exploits. We also have things like smart contract risk. If your smart contract is not properly audited, there are basically risks that are associated with that, which could result in loss of funds. Things like reentrancy attacks, oracle manipulation, access control errors, and also legal uncertainties. This falls under regulatory challenges, compliance issues, jurisdictional conflicts, and also scalability issues. We'll be discussing more about things like this, and also privacy concerns. So what is the future of the blockchain? What is the future of the blockchain? So we have things like scalability solutions, which would be L2 protocols, sharding, new consensus mechanisms. We have privacy enhancements, things like zero knowledge proof, and other cryptographic techniques that would balance transparency with confidentiality. We'll be talking more about zero knowledge proofs in the course of this program. Then we have cross-chain compatibility, which enables different blockchains to communicate and share data seamlessly. And we have mainstream adoption. We need to integrate blockchain technology into everyday use. We need to integrate them with existing systems and regulatory frameworks. So that brings us to the end of the first week of our blockchain program. See you in the next one.